Mr. J again. This time, so we're continuing with solving trig equations. This is part 2 of a 3-part series. Please note they will not be uploaded all at once. This time we are talking about the functions secant, cosecant, and cotangent, or in other words, the reciprocal trig ratios. So let's go ahead and let's get started by going about solving the equation that you see in front of us. 2 plus 5 secant theta equals 12. So the first part of the process is the same as for part 1, and that is we want to get the trig function alone. So subtract 2 from both sides, giving us 5 secant theta is equal to 10. Then we go ahead and we divide by 5. So now we've got secant theta is equal to 2. Now this is the point where it gets a little bit different, and that is, you notice values of secant, cosecant, and cotangent are not on the unit circle. So what we want to do here is we want to write it in terms of sine or cosine instead of secant. So secant is 1 over cosine. And by the way, 2 as a fraction is the same thing as 2 over 1. Well, okay, so what we can do, and I'm going to move over to the right just so I can have more space, is we can go ahead and we can flip both sides. So we can take the reciprocal of both sides. So we do that, and we get cosine theta is equal to 1/2. Okay, well, we can find that on the unit circle, because cosine is just the x value. So x value of 1/2 would be right here at 60 degrees. So that's one of our answers. And an x value of 1/2, try to move this to the side. An x value of 1/2 will also occur down here. So again, we're looking at an x value. So down here at 300 degrees. So 60 degrees or 300 degrees. Okay, and those are our answers. So now, let's go ahead and let's solve this equation right here. Okay, so, by the way, a couple differences here. First of all, this is in radians, and you notice that this is a somewhat more complicated equation. Okay, similar to what we did on the last video involving this, we're going to want to distribute this denominator. So we're going to want to rewrite this as 14 over 2 plus 4 square root 3 over 2. Again, we keep the other side the same. And then 14 divided by 2 is 7. And then, again, we would divide the numbers outside here. We don't divide the square root. We just leave it there. So 7 plus 2 square root 3 is equal to 7 plus 2 cotangent of theta. Okay, now we want to get cotangent alone. So subtract 7 to get rid of that. And as it turns out, 7 minus 7 is 0, so those cancel. And then divide by 2. And I'm going to go off to the side to give myself more room. So we've got cotangent theta is equal to the square root of 3. Okay, now here's the thing. So square root 3, we're going to do a similar technique to what we did in the other video, and that is we're going to write it as square root 3 over 1, and then we're going to divide the bottom and the top by 2, because you notice we typically on the unit circle have ratios that are over 2. So we go ahead and we do that. We get cotangent theta is equal to square root 3 over 2 over 1 over 2. Okay, now, so tangent was y over x. Well, okay, cotangent is that flipped. So cotangent would be x over y. So now we are going to look for angles where we get, and by the way, again, similar to the last video, this is the same thing as a negative divided by a negative. So we could also have negative square root 3 over 2 over negative 1/2. So we're going to look for angles where we have x equal, so either x is square root 3 over 2 and y is 1/2, or where x is negative square root 3 over 2 and y is negative 1/2. So let's go ahead and let's take a look at the unit circle and let's find some of these angles. Okay, so x is square root 3 over 2, y is 1/2. Well, immediately right here at pi over 6, because we're solving in radians, that's one of the angles. Okay. Now they could also both be negative, because again, a negative divided by a negative is a positive. So if x is negative 1/2, if x is negative square root 3 over 2 and y is negative 1/2, so negative square root 3 over 2 and negative 1/2 is right over here, and that's 7 pi over 6. And that then gives us our answers. Okay, so now let's look at one more example. Okay, so here we've got 5 plus cosecant of theta minus pi over 12 is equal to 7. Okay, so similar process to get started. So we are going to subtract 5 from both sides, which will then give us cosecant theta minus pi over 12 is equal to 2. Now, because order of operations, we're going to leave what's in parentheses for later, because remember, equations, we do it in reverse. Normally we do the parentheses first. Equations, the parentheses comes last. So now we're going to have to start out by rewriting cosecant. Well, okay, cosecant is 1 over sine. So now we've got 1 over the sine of theta minus pi over 12 is equal to 2. Okay, and again, so we can rewrite 2 as 2 over 1, and we can take the reciprocal of both sides, which would then give us sine of theta minus pi over 12 is equal to 1 over 2. Okay, so now we are looking at finding where is y 1/2 in the unit circle, because again, sine corresponds to y. So we take out our unit circle. Okay, so y is 1/2 right over here at pi over 6 radians. Or y equals 1/2 over here at 5 pi over 6 radians. Okay, notice I kept the theta minus pi over 12 because, again, this inside has to be equal to that for it to be 1/2. And something I'm going to point out off to the side here is that, okay, sine of pi over 6 is equal to 1/2. So that would mean that this inside would have to equal pi over 6. Similar would go for 5 pi over 6, because, okay, so sine of 5 pi over 6 is equal to 1/2. So the inside would have to be equal to 5 pi over 6 for that to work. And yes, in case you're wondering, that does mean that we've got one more step, because you notice we don't have theta alone. So yeah, now we got to add pi over 12. To both sides on both of these equations. Now, something I'm going to point out. Pi over 6, I can multiply the bottom and the top by 2, which would then give me 2 pi over 12. And so 2 pi over 12 plus pi over 12 would give me 3 pi over 12. And if I wanted to, I could reduce that to just being pi over 4. So that's one of my answers. And similar here, 5 pi over 6, I can multiply the bottom by 2 and the top by 2, which would give me 10 pi over 12. And so if I add pi over 12, that would give me 11 pi over 12. And after all that, we are done. Thank you for tuning in. Let me know if you have any questions, and have a great day.